Welcome to Critical Path Podcast.
Yeah.
So you have definitely seen the news. It's everywhere.
Oh, it's impossible to miss. Operation Absolute Resolve.
Exactly. The intervention in January, Nicolas Maduro is out, and the market reaction was, well, it was instantaneous.
Instantaneous. And everyone assumes the same thing, right? The bad man is gone, so the oil spigots just turn back on.
Wall Street is basically pricing in a flood of crude oil hitting the market.
Which is where the fantasy collides with physics. Because the fact that so many people miss, even analysts, is that Venezuelan oil, it's not really oil in the way you picture it.
It's basically road tar.
It is. I mean, think about your benchmark crudes, Brent or WTI. They're around, 38 degrees API gravity.
Yeah. Right. They flow.
This stuff from the Orinoco Belt, it's between 7 and 10 degrees API.
It sinks. It would literally sink in the ocean.
Yeah, the viscosity is just insane. I saw it described as cold honey, or this is my favorite, molten shoe rubber. That's the stuff everyone's so excited about.
Molten shoe rubber. That's not an energy source. That sounds like a geological prank. You can't just pump that. This is Critical Path, where we explore stories and innovations about our global supply chain that connect our world to your everyday life.
And today, we're essentially conducting an autopsy. We're looking past the headlines of the military operation to get to the logistical truth.
The truth being, you can't just reboot an industrial complex that's been, frankly, cannibalized for 2 decades.
You can't. So our focus today is on the logistical impossibility of bringing this black goo back online anytime soon.
Okay, so let's start with the physics. This viscosity trap, the Orinoco oil belt.
Right. It holds something like 1.3 trillion barrels of this extra heavy crude bitumen, really.
So how on earth do you even get something like that out of the ground?
You have to melt it
Yeah.
in place. It's a process called thermal recovery.
You're boiling it underground.
Pretty much. The most common way is called huff and puff. You use these giant boilers to create superheated, high-pressure steam, and you inject it deep into the reservoir.
Wow. That alone sounds incredibly energy intensive, and that's just step one.
Oh, yeah. Step one, because once you get that sludge to the surface, the real logistical nightmare begins.
Because if you put that stuff into a pipeline,
It cools down, it solidifies, and your billion-dollar pipeline becomes a very long, very useless asphalt plug.
which brings us to this critical loop, the diluent dependency.
Precisely. To make the sludge flow, you have to dilute it. You have to mix it with something much, much lighter.
Historically, that was naphtha, right? A refined product.
Yeah, often imported from the U.S. Gulf Coast, ironically. So you see the loop.
It's a two-way street, a very vulnerable one.
You have to import the light stuff, pump it hundreds of miles down to the fields, mix it, and only then can you pump the blend back up to the coast to sell.
So when the U.S. sanctions hit in 2019 and cut off that naphtha supply,
The whole system just seized up, production froze. If you can't dilute it, you can't move it. It's that simple.
so what did they do? I mean, how did they keep anything flowing at all?
It got very complicated. They had to rely on these diluent swaps, mostly with Iran and Russia.
So Iran would send them something light, like condensate.
Exactly, a very light crude. And Venezuela would pay them back with their heavy sludge. It was all done through these shadowy ship-to-ship transfers, tankers going dark, turning off transponders.
Just to keep that critical loop turning.
A high-stakes barter system, really.
And here's the kicker, even after all that, the steam, the imported diluent, the secret swaps, the stuff you get, still can't go to a normal refinery.
No way. It's still too heavy, too acidic. It's full of heavy metals like vanadium and nickel.
Which is why the upgrader bottleneck is the real critical path here.
The absolute non-negotiable step. In the 90s, they brought in the big international oil companies to build 4 colossal industrial plants at the Jose Industrial Complex. Petropier, Petrostenia.
And these aren't just refineries. They're more like massive chemical conversion factories.
That's a great way to put it. They take that 8-degree API bourbon, and through a process called delayed coking, they basically transform it into a marketable 22 to 32-degree API synthetic crude. Syncrude.
So no upgraders, no money.
No upgraders. You're just trying to sell sludge at a massive discount that nobody really wants.
And the complexity is just staggering, which makes you wonder, how did a country that was capable of this level of engineering fall apart so badly?
Yeah, you have to go back. Back to what people call the golden era. For most of the 20th century, Venezuela was the Silicon Valley of oil. Their engineers were world-class.
And the nationalization in 1976, that wasn't a hostile takeover. It was called the gentleman's nationalization.
It sounds so quaint now, doesn't it? But it's true. They kept the structures. Shell's operations became a company called Marathon. Exxon's became Lagovin.
So the institutional knowledge, the meritocracy, it all stayed in place.
It did. And PDVSA, the state oil company, was consistently ranked the second best in the world. But that's also where the problem started.
How so?
That highly competent meritocracy, it clashed with the political goals of Hugo Chavez. The engineers wanted to reinvest profits to maintain the fields, for long-term health.
And Chavez saw PDVSA as a piggy bank.
An ATM for his social programs. That conflict just boiled over during the 2002 general oil strike.
And what happened next is it's a case study in destroying human capital.
With a whistle,
Right.
literally. On his weekly TV show, Al Presidente, Chavez would hold up a soccer referee's whistle.
You're kidding.
Not at all. He'd read the name of some senior reservoir engineer, someone with 30 years of experience, blow the whistle and just yell, "Fuera!"
Oh.
Just like that. 18,000 employees, geologists, operators, managers, the entire institutional memory of the company liquidated live on television.
But the collapse wasn't immediate, which must have been so deceiving.
That's the Mirage Gap. It's a classic lagged collapse. Oil fields have inertia.
And oil prices were going through the roof back then.
Yes, exactly. From 2004 to 2014, with oil at $140 a barrel, the cash was just flooding in, even as they stopped all maintenance. So on the surface, it looked like a brilliant success.
Well, underneath, the engine was seizing up.
They were causing permanent structural damage to the reservoirs that you just can't undo easily.
So when oil prices finally crashed in 2014, that's when neglect turned into something much worse.
It turned into active cannibalization. And we need to be clear, this wasn't just theft. It was looting.
What's the distinction?
Theft is taking something of value. Looting is the destruction of value. It's destroying a $50 million control room to sell $5,000 worth of scrap copper.
The copper epidemic.
Yeah. Gangs would rip out copper wiring from substations. But to get the copper, they'd wreck everything else. The control boards, the fiber optics, the whole facility would go blind.
And the few workers left behind were trying to keep these places running with what?
With nothing. There are these chilling stories from refineries like El Polito. Workers using actual pieces of wood to patch leaks in high-pressure steam lines. Wood. Because they didn't have a simple steel clamp. The places became these Frankenstein's monsters, just held together with scrap parts and hope.
Which leads to the ultimate irony. A country with the largest oil reserves on the planet
Had chronic gasoline shortages.
Yeah.
They had to start importing fuel from Iran.
And if you need one visual to sum up all of this decay, it's Lake Maracaibo.
The birthplace of the whole industry. It has 15,000 miles of underwater pipeline.
And they're all leaking.
Profusely. So you have constant oil slicks, which is pure carbon. At the same time, all the city sewage plants failed, also from looting, and started dumping raw sewage into the lake.
And sewage is full of nitrogen and phosphorus.
So you have carbon, nitrogen, and phosphorus. It's the perfect food.
A recipe for an ecological disaster.
An explosion of lemna or duckweed. Satellite images today show this huge neon green carpet covering the lake. It hides the oil, chokes the boats, and releases poisonous gas as it rots. It's a dead zone.
Okay, so let's fast forward to January 2026. Operation Absolute Resolve happens. The geopolitical deck is cleared. But the physical reality is that dead zone you just described.
Right. And just before the operation, PDVSA was running what it called a resistance economy.
This was the ghost fleet.
Yep. Tankers going dark, faking paperwork, doing risky ship-to-ship transfers off the coast of Malaysia.
All to hide the oil's origin and sell it mostly to China. It was a logistical nightmare.
It was. And the operation itself, Absolute Resolve, was actually a masterclass in logistics.
What was the key element?
It started with a tactical cyber attack. It blacked out Caracas, which created the opening. But they'd also built a full-scale replica of Maduro's compound, Fuerte Tiuna, somewhere classified, and rehearsed the entire raid for months.
Incredible. So the military action was clean. The political risk is gone. Why isn't the oil flowing?
Because the operation removed the squatter, but it didn't fix the house and the state of the house. It makes the market's optimism look completely detached from reality.
Let's get into this reconstruction nightmare. The numbers being thrown around are they're staggering. 100, maybe $200 billion in CapEx.
Over 7 to 10 years. And that's because you aren't just restarting things. You are rebuilding from the ground up.
The wells that were shut down improperly are now plugged with solid bitumen.
They have to be re-drilled. The pipelines are basically sieves made of rust. If you tried to pressurize them, they'd leak everywhere. Every single pump, valve, and compressor has to be rebuilt or replaced.
And this is where we hit the upgrader trap. These aren't simple machines.
Not at all. You can't just order parts for these on Amazon. They require custom-built compressors, highly specialized pumps, all from the original equipment manufacturers, the OEMs.
Companies in the US, Europe, Japan.
Siemens, GE, Mitsubishi, and they don't have these things sitting on a shelf.
So what are the lead times?
You are looking at 18 to 24 months, minimum, just for delivery. Then you have to install it, test it, commission it.
The timeline isn't set by politics. It's set by global manufacturing cycles.
Exactly. And that's before you even think about the people.
The 18,000 engineers. The human capital.
They're gone. They're driving Ubers in Miami or working for Shell in Qatar. To get them back, you need to offer dollar salaries, physical security, reliable electricity.
Conditions that just don't exist yet. You have to rebuild the entire technocracy.
And just to add one more layer of friction,
Yeah.
the shipping insurance market is already reacting,
What do they do?
adding war clauses to any freight going into Venezuela. So every piece of equipment, every steel pipe, every bag of cement you need for the rebuild just got exponentially more expensive to import.
So to wrap this all up, the Black Goo paradox is this. Operation Absolute Resolve was a perfect military operation. The squatter's gone.
But the new owners have just been handed the keys to a mansion that's been used as a crack house for 20 years.
And the treasure in the vault is trapped behind walls of viscosity, entropy, and just brutal logistical friction.
The real obstacle here isn't the politics anymore. It's the physics. It's the simple, unchanging reality of how long it takes to custom build a highly specialized compressor in Japan and ship it across the world. The supply chain has the final vote.
So here's the thought to leave you with. Which is the more powerful force in our world? The swift, kinetic power of a military intervention, or the slow, grinding reality of a 2-year manufacturing lead time?
It's a good question.
Thanks for listening and watching. Please like and subscribe, and make sure to check out our other podcasts.